Welcome back, my intrepid statistics students. Now that we've covered chapter 7 and 8, hypothesis testing and confidence intervals for one sample, we're now going to deal with the situation where we have two samples, or two populations that we're going to compare head to head. So our objective for today is to compute and interpret hypothesis tests and confidence intervals for two independent proportions. And as we've mentioned, we've only taken one sample at a time before, but now we're going to take two samples and compare them against each other. And we're going to start by dealing with proportions. And since this is going to be a proportion, it's going to come from a binomial. So we need to have some requirements met before we can know that our techniques are going to be valid. The first is that we have to have two random and independent samples. Okay. Second is that we need to be a binomial. And we've done this many, many times. The requirements to be a binomial are: one, a fixed number of trials; two, it can be organized so that there are two outcomes and only two outcomes, which we've commonly called success and failure. And three, the trials are independent. So that means that the probability of success needs to be a constant. Now, to make sure that our sample sizes are large enough, we need to check to see that NP is greater than or equal to 5 and NQ are greater than or equal to 5. So, but we don't know little p and we don't know little q. So what we do is, like we did with our confidence intervals, we say that the number of successes is greater than or equal to 5 and the number of failures is greater than or equal to 5 for each sample. Okay. All right. So let's take a look at a problem where we take a look at a hypothesis test for the difference of two population proportions. And again, we're going to do one hypothesis test, but it's going to see if they are different or not. Okay. So a pharmaceutical company is testing the effectiveness of a certain drug in preventing subsequent heart attacks. 187 people who have had a heart attack in the past meet the conditions to participate in the clinical trial and are randomly and independently divided into two groups. 100 people go into the experimental group, the group that gets the new drug, and 87 go into the control group. They get a placebo. A placebo is a fake pill, a pretend pill, usually a sugar pill, because some people actually get better if you give them any kind of treatment at all, called the placebo effect. At the conclusion of the study, 9 people in the experimental group had another heart attack. In the control group, 13 people had had another heart attack. Does this data indicate that the drug is effective at preventing heart attacks? And we're going to use a 5% level of significance. So first off, let's check our requirements. Did we have random independent trials? Yep. So on the homework and on a test, please note that for me. Do we have a binomial? Well, let's go through. Did we have a fixed number of trials? Yes. In the first group, we had 100, and in the second group, we had 87. Okay, so we had a fixed number of trials. Do we have two outcomes? Well, I know it's not nice or happy, but we're going to call success another heart attack. And failure would be not another heart attack. Okay. That's just because the way the problem was worded when it was set up, that 9 people had had another heart attack and 13 people had had another heart attack. So that sounds like success and failure. Success should be another heart attack. Okay. And if one person has a heart attack, that doesn't say anything about another person, so the trials must be independent. Therefore, the probability of success in each population should be a constant. Okay, and we need to decide, or we need to check and see if we had the number of successes and the number of failures were greater than or equal to 5 in each sample. So let's go ahead and we'll come back to him in just a second. Population 1, just because of the way it was worded in the problem, we're going to get, let's say that population 1 is the experimental group. Okay, the group that gets the drug. Okay, that would make population 2 be the control group, the group that gets the placebo, the sugar pill. Okay. Now, what we want to do is talk about the population proportions. So little p1 is going to be the population proportion of another heart attack in the experimental group. The group that gets the new drug. Okay. And little p stands for population proportion, so little p2 is the population proportion of the control group that has another heart attack. Okay. Now, we don't know what the true population proportion would be for either group, the group that was going to get the drug, anybody that we would give the drug to, or anybody we don't. So what we're going to do is not give up. We're going to take a sample. And since we've decided that group 1 is going to be the experimental group, the number of successes here, we had 9 people in the experimental group that had another heart attack. Therefore, the number of failures in that group would be, since there were 100 total, 91. And I'll put a little subscript 1 on these to help us remember that that came from population 1. And the number of successes in group 2, remember that a success was a heart attack, is 13. And the number of failures in group 2 would be, let's see, 87 minus 13, which is 74. And both of these are greater than or equal to 5. So we're good to go. So let's go down to the next part and write out our known information. X1 was our number of successes in group 1. So that was 9 out of 100. And P1 hat is X1 over N1, which would be 9 over 100, which to 3 decimal places is 0.090. That was really easy because he was out of 100. X2, we had 13 successes out of 87. And if we pull out our calculator, we'll find out that the sample proportion for population 2 is 0.149. Here's what I got. So 13 out of 87 is 0.149. All right, now we're going to need to introduce somebody else called P bar, and it's the kind of overall proportion. So we're going to take X1 plus X2, getting 22, and N1 plus N2, which is 187. And let's find out what that gives us. So 22 out of 87 would be, 22 out of 187, sorry, is to 3 decimal places 0.118. And Q bar, since this is a binomial, this will be the probability of success, or sorry, probability of failure will be 1 minus this, which will be 0.882. We'll pause there and pick up in the next video.